Hello, my name is Danielle Denley, and I'm a postdoc in Anne Solomon's Coastal Marine Ecology and Conservation Lab at Simon Fraser University. The project I'm introducing today was actually motivated by a photograph that was sent to us back in the summer of 2015 by First Nations Coastal Guardian Watchmen. And this photo was of giant kelp heavily covered in a white crust, similar to the photo on the right you can see here, compared to clean, healthy giant kelp in the photo on the left. That summer, the Guardians observed many giant kelp beds becoming so laden with this white crust that they actually sank out of the water column to the seafloor and died. And this was concerning for First Nations communities on BC's central coast because loss of kelp can reduce access to traditional foods and livelihoods, especially the herring spawn on kelp fishery, where giant kelp blades are harvested and used to collect herring eggs. Little did we know at the time, but these critical observations were actually made during what would later become known as the Warm Blob, that now famous marine heat wave that spanned the Northeast Pacific Ocean. The white patches the Guardians observed turned out to be colonies of an encrusting animal that grows on kelp called a bryozoan. This animal has a planktonic larval stage, and then it settles and grows primarily on kelp. And both recruitment and growth of bryozoan colonies on kelp are strongly positively related to ocean temperature. And this means that outbreaks of this bryozoan can be triggered by rising ocean temperatures and have actually caused substantial loss of kelp in other parts of Canada, such as off the coast of Nova Scotia, as well as elsewhere in the world. We know from previous work that kelps on BC's central coast are already sensitive to small sub-regional variations in ocean temperature of less than a degree. This suggests that climate change will have a direct negative effect on kelp forests on the central coast, and climate change is also predicted to have a direct positive effect on population growth of the bryozoan. So what we don't yet know is how the indirect or hidden impacts of climate change, mediated through potential increases in the frequency and magnitude of bryozoan outbreaks, will impact these kelp forests. And so this question is the motivation behind a collaborative research project between our lab at Simon Fraser University, the Central Coast Indigenous Resource Alliance, which encompasses all 4 First Nations communities on BC's central coast, the Heiltsuk, Newhalk, Wekenow, and Kitasoo-Hehe Nations, and the Pacific Institute for Climate Solutions. And this project is aimed at identifying the main drivers responsible for increased growth of bryozoan and its impact on kelp on the central coast, and developing management solutions in response to these impacts. To achieve this, we're conducting traditional and local ecological knowledge interviews to establish critical baselines for changes in the distribution and abundance of both kelp and the bryozoan on the central coast. We're complementing this with contemporary field surveys to identify spatial patterns in the seasonal timing and abundance of bryozoan on kelp. And we're using this information to inform manipulative experiments that will be based on traditional harvest and translocation of kelp practiced by coastal First Nations in order to explore the effectiveness of potential adaptive management strategies. And importantly, we are working with SECURA, the nation's stewardship offices, and their Coastal Guardian Watchmen to co-develop an iterative process of continued monitoring and adaptive management in response to spatial and temporal variability in bryozoan growth on kelp that can continue beyond the duration of this project. This is particularly relevant off the coast of BC, where on top of general warming trends in the Pacific Ocean, we are seeing an increase in the frequency and magnitude of marine heat waves, like the Warm Blob of 2015. And so we really need to be able to detect and respond to these events at local scales and in real time. Ultimately, the goal of this project is to inform adaptive ecosystem-based management of kelp harvest and related fisheries to minimize negative impacts of temperature-induced bryozoan outbreaks and increase the resilience of both kelp forest ecosystems and the coastal communities that rely on them to climate change. And I'd just like to thank and acknowledge our research partners at SECURA, as well as our funding agency, the Pacific Institute for Climate Solutions, and of course MEOPAR for the additional financial support and for this exciting opportunity to be part of the MEOPAR network. So thank you.